Hello, good morning. Welcome to another episode of Xahlee Talk Show. We are going to code emacs lisp today. We are going to continue from 2 days ago. So about 2 days ago, we did one that is on May 18th, episode 657, emacs lisp generic map functions on hash table, associative list, and property list. So today we are going to continue that, and I'm going to do write a tutorial. So basically we are going to cover these new functions in emacs lisp. Okay, so this is good for you emacs users, programmers, and emacs lisp coders. If you are watching offline, play at 1.5 speed because I ramble. If you are watching live, say hi. Love to see your comments. Okay. Nobody's here, so let me. I'm just gonna start to work on it. Okay. So the problem is we got this. So let's go to the previous talk show. So this is 659 is today. 657 is the 2 days ago. Okay. So you got, so let me copy that link. Okay, go back here. Let's begin. Paste the emacs lisp hash table and grab those code. Okay, so the job today is to write a tutorial for these new map functions. Write a tutorial into my emacs lisp basics tutorial, okay, on xahlee.info. So something we need to refresh. We need to know when is this. So there are a few information. Let me just quickly add it. Okay, so yeah. So actually go to the talk show. Something I want to know. Okay, so why don't we just copy the thing, close it. Wait. So yeah, okay, so that's good. Close it, reopen it, showing browser. Yes, okay. So these functions we need to write, and so let's add some links here. Emacs basics and hash table, write a tutorial. So there are a few things we want to know. Write a tutorial and check if all these functions are preloaded when you load Emacs. Because if they are not preloaded, then every time you use them, you need to say require something. Very annoying. So check, look into they are created. Check Emacs news file. Okay, so there are a few things we already know. They are created. Okay, so let's. Okay, so how do you know if they are preloaded? The most simple way is just to start Emacs. So you can say run Emacs -q. -q means do not load any ini file. Okay, so if you control C. Okay, let's try again. Run Emacs -q. So you see it launches a new Emacs. Now Control Shift up arrow. Wait, not Control Shift. Alt Control scroll up to magnify the font for every window. That's a new Emacs feature about a few years ago. Okay, so you can see. So we need to try to use one of these functions. So for example, let's go to last time. We have an example of calling this map apply function. So copy it. So back to this plain GNU Emacs. So so we are using Emacs keys. So switch buffer is gonna be Control X B. Okay, go to scratch buffer, Control Y to paste. Okay, now that's not big enough, so Control Alt scroll up. So now we got big. Now the font is not too good. Yeah, but let's leave it with it. Okay, so evaluate this. Control X, Control E, Control X, Control E. Okay, done. And do the same here. Then do the same here. Void function map apply. What? Okay, so it's actually not loaded. I thought it's loaded because I tried it yesterday. What? Okay, so apparently this function is not loaded. Okay, so by default it's not loaded, so that's a good thing to know. If the map.el lib is preloaded, answer no. Okay, and okay, so they are created. So okay, so Emacs version history. The map.el lib is created in 2015, so 10 years ago. Okay, so we know the creation date, we know, and it's not loaded. That's annoying. So if it's not loaded, that means you need to let me map apply. So describe function map apply, jump to the source code, jump to the bottom. That's how you that is that provide. That means you, so you need require. That's what you need to call if you want to use any of those functions. But I'm surprised that it is not preloaded, because I thought I tested. So copy. Now Control Y to paste, Control X, Control E to load it. Now we Control X, Control E. Okay, so now it works. So I'm pissed that it is not preloaded. Let me try again. Okay, so Control X, Control C to close that. And let's just try it again. Copy. Okay, so go to xx.el. Okay, create a file xx.el, paste that there, and let's say, let's just remove that to there. Okay, so simplifies. You don't even need a list, so you just run that, save it. Okay, now go to shell, start Emacs again, do it. Okay, now, yeah, this is so tedious. Control Alt, scroll up to magnify. Okay, done. Now Control X, Control F to open a file, xx.el. Okay, now move cursor down, Control X, Control E. Okay, so now finally we know this function is not loaded by default. We finally verified it for sure. That's painful. Okay, so these are the few informations that's critical when you write a tutorial, because you want people to, you need to tell people that you need to tell people when is it created and what do you need to load if you want to use it. Okay, so, and also another thing I found out is that these functions are not documented in Emacs Lisp manual. Okay, so for example, search for map applies, copy it. Now search for Emacs Lisp documentation, Emacs Lisp manual, search, none found. So the command you call is this elisp index search. Okay, so try it again. Map apply, it's not found. Now go to the emacs lisp info directory. Let's try to grab it. So is it possible that it's in the info file, it's just not in the let's open any one of them. So search for map apply info, none. So this map apply, so these functions are not documented at all, which is very informative, because that says these are kind of advanced functions that it's not documented, so it's only for advanced users. I'm not sure why they do not document it. Try another one. No, not found. Okay. GNU Emacs for success. First, hello first, hello Diego. So that this is quite interesting to know that these functions we are trying to document to write a tutorial today, they are actually not documented in the Emacs Lisp manual officially. It kind of makes sense because, like I talked about the other day, hash table or hash table data structure or the association list structure or the property list or the symbol property list, they are all a collection of pairs and hash table. Okay, hash table is here. So they are all collection of pairs, and each one of them, the data structure, they have their own, native functions to deal with them. So technically, you do not need, these extra functions, but they provide it so it's, for one thing, it's more consistent. So you can use any of these functions to deal with any of association list or property list or hash table. That's one thing. Convenience. I mean, convenience and consistency. Okay, but the other thing, more important, is that some of these functions actually you don't have a functionality. Like map filter. I don't think you have a function in hash table that filters by key. So they actually provide new functionality, because if you don't have these functions, you have to write it yourself, which is very tedious. Like when you start programming, these are kind of things you do. In almost any language, in Python, in Perl, in Wolfram language, in Lisp, like how do you partition a list into, let's say, every item is 3 elements. Suppose you have a list, you want to make it a list of lists, and each sublist is 3 elements, okay, or 4 elements, or n. So how do you have to write a function to do that? So there are many ways. So this kind of, for example, you can look at Emacs Lisp basics. Function take, drop, slice, then map for every sequence. All these work on list for every filter, remove, sequence keep. They delete elements or keep elements sometimes by a function. If the function is returned true, they keep it or remove it, or sometimes by a exact literal element. So anyway, so these list functions, there are so many, and how do you write a unique, if you want to delete or duplicate in a list? right? So you have all these kind of tasks: sort, reverse, join, convert, union, intersection, difference, partition, and group. So typically for beginners, these are very interesting programming exercises. Like I did this in 1990s with Wolfram language. Wolfram language already has all this built in, but then you still need to do more. So, and Python added them like after 20 years. They add Python like today. Most languages has union, intersection, and difference. Okay, so they are in Wolfram language since like 1989. Okay, a little bit digression. So let me show you Wolfram language. So you go to list data structure. You go to Wolfram language in depth, table of contents, numbers, boolean, list. So list operations, you can get parts, add elements, delete elements, change element, check existence, filter, sort, reverse, or get their order, reshape, split, group, fatten, transpose, count, group, similar items, combinatorics, that especially this combinatorics, very interesting. For example, tuples, you want to get all possible list of two things, or all possible list of three things, and all possible subsets. These are kind of combinatorial mathematical functions. Or you want to get all possible permutations of a list, or all possible subsequences of the list. So so one of the basic is union, intersection, complement, or difference. So Wolfram language had them in 1989 or so. Python added them around pretty late, 2008 or something. So but by today, like most languages has this union, intersection. But the many things Wolfram language provide, tuples, subsets, permutations, they don't have in other languages. In Python, some of them they added it, but in a special library. Okay. So anyway, so what I'm saying is that these kind of things are almost the very interesting programming exercise for beginners when you learn a new language. And so similarly, so I was saying, so in emacs lisp, so they started, you see, emacs lisp added these sequence functions about 10 years ago. So, and today they added these, generic map functions. So if you don't have them, you have to implement them yourself. But usually it's problematic because to implement properly, you have to be concerned about efficiency. And also, if you're gonna do all of these, then the design becomes critical, like because you don't want each one of them having different arguments, order, or whatever. So it is actually critical to have a consistent set of these functions built in the language. So that is why this emacs lisp, they added this 10 years ago, which is great. You got merge with, merge, map nested elements, map pairs. Yeah, but somehow they are still not documented in emacs lisp manual. So, but anyway, it's a positive thing. Okay, so we learned, it came from 10 years ago. And it where is it, part 2? Okay, so 10 years ago, and it's by default it's not loaded, and also it's not documented. Okay, we already okay, that's what we know. Now let's begin to write a tutorial. So I decided last time to add it after the hash table. So you go to hash table, you go to emacs lisp basics, then you got the data structure section, you got list, special list, and the list structure, count cells, then vector, then you got these sequences, generic list manipulating functions, then you got hash table. So the map functions, I decided to add it after the hash table. Okay. So so what would be the name? Map functions. Okay, so let's just say map functions. Okay, so map functions. Let's say generic, no shortcut. Generic. There's general. Okay, well, I want generic. No. Okay, so that would be the name, general map functions. Now, open the hash table page, copy it, close it, open this page, do it, paste it, save it, close it, cut the title, undo, open it again. Now change the title, emacs lisp generic map functions. Okay, go to the top, showing browser, there it is. Now I need to delete those. Okay, I start to write a tutorial. So update the timestamp, remove the old time. What is generic map functions? Okay. Starting to write a tutorial. Okay. These are general, let's say generic functions that they work on okay, so they work on, let's go to Lisp basics, data structure, they work on association list. Okay, copy that, split the page, go back to the hash table, jump to previous location, there, and hash table. Okay, copy the link there. Okay. Okay, then delete that. These are generic functions that work on these things. They are created around, they are in Emacs around 2015. Important information to use them. Okay, to use them, you need to load. Okay, so what is the I do remember, but okay, so let's just write it. Require map dot require map. I think so. What is it? So comments, questions, post it. Okay, I'm gonna get to it. What is this? This is so they require. Okay, require. Yeah. Map apply. Go to the source code. Go to the bottom. Provide map. Okay, that's what you need. Close that. Yeah, just map. Okay. So make it that they are in Emacs around 25. To use them, you need to load the library. They are in Emacs 2015, and go open the Emacs version history page. So 2015, they are in Emacs 25. Okay, last time we checked, it's in Emacs 25. Okay, so close. Okay, so they are in Emacs 25. Okay, that's one thing. Okay, and they provide a general way to work on any of whatever. Okay, so let's something like that. Okay, this is just a draft writing my tutorial and create a hash table. We don't care. Literal expression for hash table: delete length, add entry, remove entry, check exist, check keys value, remove all entries, apply function to all entries, get all keys, get all values, and reference. Unfortunately, they are not in Emacs list manual. So now show in browser. So now is our draft version of the tutorial. Okay, now go to the talk show. We need to grab close. We need to grab the list of functions. Okay, part 2. Okay, so let's grab them, cut, save, go back, show in browser. So we need to work on each and every one of them. Okay, so there it is. And now copy the file path, close it. And what is this today's talk show? Let's paste them there. Okay, so wait, where do we want to paste? So this is part 2. This is today. So oh, you already have it here though. So okay, yeah, identical. So but before, so now we need to remove these others. Let's just clean up. Okay, remove this Emacs 25. Yes, Emacs 25. Remove version history. Remove xahlee keys. Remove show. Okay, so edit basics hash table, write a tutorial. So let's go to the front. So we write a tutorial. The map.el lib is created in 2015. Look into the map.el library is loaded, preloaded. Answer no. Okay, so this basics hash table is repeated. Delete. Okay, merge the two lists, show. Okay, this basics hash table generic map functions. Okay, go there. Fantastic. Now so now this is an introduction what is generic map functions, and introduced in 2016, and you need require map. Okay, and also mention they are not documented in Emacs list manual. Okay, so let's go. Where are we? Okay, so go to the page. Mention they are not documented in lisp manual. Okay, in version 30. Okay, for Emacs version 30. Okay, this is just a draft introduction. We need to refine it because so far we don't know if it works on symbol property list. We know it works on association list, property list, but I don't know if it works on symbol property list. So we need to check each one of them. Now go back here, close that, go back, subsequences. Okay, this Wolfram language, very interesting thing. So why don't we copy it, because we talked about it. So close. Okay, so now paste that there, and this is what we want. Okay, so the others are just supplementary links. Okay, and we talked about list basics. We talked about this bunch of sequence functions that's very suitable for programming exercise, such as let's see, sequence functions. For example, union intersection. Some of these are actually interesting ones, and they are added recently, actually. So let's put that there first. Okay, so for example, the sequence functions, there is one called, like all these are, they are especially useful if you do functional programming. This map for each sum and every and filter, they are especially useful. Mostly their purpose is for if you do functional programming, because otherwise most of the time you just use do times, like a loop. So the power of these functions is actually for functional programming. Okay, and there are some quite interesting ones. So for example, the partition and group is very interesting ones. They, it's like sometimes you don't see this in let's say Go language or Java. I'm not sure, but usually you don't see them. But in functional programming, in Haskell or Camel, you kind of see these. Okay. So some of them is interesting. For example, one of them I want to show is very powerful. Okay, so for example, reduce is very powerful. Take drop slice iteration guide. Where is reduce? For each map, map car, map indexed. Map index is also an interesting one because you want to map a function to a list, but sometimes you also need the index. So that's why you have map indexed, and this is for functional programming. Because if you don't do functional programming, then you just do loop, do times. But there is another one I wanted to show. Anyway, so we are digressing. So let's get back to focus on writing the tutorial. Okay. Okay, so here, so we want to, so first of all, we need to get the example. Let's just write like one documentation for one of them. Then I'm gonna work offline for the rest, just to show, how do I write my tutorial. The structure, the design, what you need to know, what you need to prepare to write them. Okay, so let's go back to generic functions. So let's create a new section. Let's say, okay, emacs lisp. Okay, so first of all, so this is gonna be map apply. This is gonna be map apply, and describe function. Let's see what is the syntax. So that is that, and now call xah bracket capitalized words. So you will see why. Okay, so let's add a definition list, and let's make it add the code tag and variable tag. So you can see in browser they became a definition list like that. So the var indicates they are variable. I mean they indicate not literal. Okay, the red is literal. So you can see by a glance this design, this design of technical writing format. So you see in my style you have this they are green. That means that string can vary. Okay, so anyway, so that you got that. I want a bracket there, and then you need to say what it does. Okay, so basically this is what it does. So we can base it off on the inline documentation. Okay, so but I want to write my own style. So apply a function to each element of map. Okay, return the result as a list. Okay, function is called with two arguments, a key and value. Key and value. Okay, the default implementation, it's I don't care about that, because I want to cover the mathematical properties. How it is implemented is another issue. Okay, basically it would be something like that. Okay, then you need the example there, and we need to simplify the example. Okay, so like I said before, we just put that there, and then this AA just X key for clarity. So say key and value. Okay, so prettify, delete, and okay, that's the output. Okay, syntax correct, show in browser. So here is one of them kind of done. Okay, so we can kind of, so this needs to be apply bracket, that curly brackets, I mean that's French bracket, that's French single bracket, also do that there. Okay, then make it tag. Okay, that's kind of better. Also, it is another detail here is that it is very annoying that in Emacs convention they capitalize the arguments. So for example, let's go close that, reopen to remove this highlight, remove. Okay, so let's describe function. So you see map apply. So let's, here's the documentation, and let's jump to the source code. Okay, so you can see here's the source code, and here is the inline doc string, and you can see they capitalize this word function, and also they capitalize this word map. Why? Because they are part of the argument. So it is Emacs documentation convention that for any arguments or parameters of the function, you capitalize it. Okay, that's a Emacs convention. You can see it by, in my Emacs Lisp documentation page, Emacs Lisp, and okay, so Lisp basics, you go to the function section, data structure, function, define function, function parameters, docstring markup. So this page shows you how to write the documentation string, just like here, and certain conventions. So if you have a parameters for a function, you need to capitalize them by convention. Okay, and this convention is very bad because in Emacs Lisp, the programming language is case sensitive. So if you have a parameter of capital A and a parameter of lowercase a, they mean different things. But now in the documentation, they become the same thing because to refer them, you capitalize it. So now they become the same thing. So it's no good. It's ambiguous. It makes it, it's ambiguous. So this is a bad convention. But why do they do it? Because by convention, you don't capitalize your arguments parameters. So effectively, the entire Emacs Lisp source code bundled with Emacs, the arguments are not capitalized. So therefore, you can capitalize it in a docstring to distinguish it from common English words. That is why they are doing it. Okay, but it's a bad convention. They shouldn't. If I lead Emacs, I would change it. But it's Emacs is like 40 years old. There's a lot of history. Okay, are there lazy sequences in eLisp? No, and that's a good thing. Okay, lazy evaluation is one of the worst shit. Lazy evaluation is not good, such as using Haskell. Okay, but further, what is worse is when you have iterators and generators, such as in Python and JavaScript. That is far worse. That's the worst shit possible. They are kind of related because lazy evaluation is related to the iterators and the iterators, generators. Very complex shit, because they make, what they do is that they, you have things like that, lazy evaluation, for the purpose of, part of the purpose is trying to be efficient in saving memory usage. Because if you have a list of 1,000 items, sometimes you may not need to use all of them. You only want to use, like 1 to 100, but potentially you want 1,000 of them. So traditionally, you just create a list of 1,000 items. So it wastes your memory, because you don't necessarily actually use it. So then you have lazy evaluation, which is a mechanism that allows you to have a list of even million items or even infinite number of items. But they occupy memory only when you use it. Okay, so I believe that is basically essentially just what iterators for. Okay, so for example, in JavaScript, JavaScript in depth, and you have this entirely complex thing called function class iterable. Okay, you got iterable object, you got iterator, then you got iterator prototype, you got iterable prototype, which in JavaScript they call interface. Actually, they call it protocol, and it's extremely complex. So once you have that, iterators and iterables in JavaScript, by the way, Python, so depending on the language, their meaning differs slightly. Okay, but in JavaScript, you have iterable, then you have iterator. They are different things. Okay, but once you have them, then you need generator. Okay, then you need generator. Fucking idiotic. And then you have generator function. Okay, so a generator is a function that creates iterable. Okay, and then a generator function is a function that creates generators. Okay, so it's fucking entirely idiotic. For what purpose? Because they want to save some memory, which I don't think is that useful, because you don't create infinite list. Okay, if you really want an infinite list, you can do it in other ways. You don't create a list. Okay, but they try to, these, so that's the idea of these iterators. So, and also once you have them, they become, the programming, the way it semantics, the runtime, it becomes hard to predict what's going on. When you have lazy evaluation. Okay, there's another thing. So I was talking about lazy list in Haskell. So that has strong ties with the iterator and generator stuff. But then there's another concept is lazy evaluation, which means whenever you call a function, the function's argument does not evaluate right away. It evaluates only when it's used. So that's another thing. So that's another thing. I don't think it's good. Okay, so I think we are done. So web dev. So we talked about iterators and we talked about function, the conventions for emacs lisp function inline documentation. So let's copy it. Let's put in our talk show. So we have some record of it. Okay, continue here. We talked about emacs lisp inline documentation, which is no good with the capitalized words, and we talked about iterators, generators, crap, and lazy evaluation. So JavaScript generators, very complex. So let me summarize. I think that's it for today. But let me tie up some loose ends on something I want to say. Okay, docstring markup, and today, did we finish it? Kind of. So this is this is the tutorial for this. So we kind of started a draft documentation for map apply. Then we need to work on each one of those. Okay, and another thing is that there is no documentation. I mean, there is no pop-up. Like you see in my tutorial, you can move the cursor to a function name, then you'll have a pop-up of the inline documentation. But I don't have it for the map apply. So let me redo this. Okay. So that means I need to regenerate my inline documentation. That's done with JavaScript. Let me show you. Okay. So generate map functions, open it, and go here. So this we got this list of things. Now press. Okay, that's what we want. Now regenerate it, so you can see they are now Lisp functions. So you see. So now if you refresh, you'll notice the difference. Let's do it. You see. So now if there's a documentation, it should show, but it's not. For example, I can show you a list. Okay, tag it, make a list, show in browser. Now go down. If you hover to list, you can see the documentation. So that is done in JavaScript. So search for .js. So you got this pop-up data. Okay, so open it. So this is a pop-up data. This is JavaScript. In fact, it's TypeScript. So you got 35,000 lines. So you need to add about 20 of these. Yeah, that requires the whole regeneration. Okay, so that's that. Okay, so I think that's it. So did I miss something? So emacs lisp is fantastic. What nature sparked your curiosity to dedicating much time on emacs lisp? Well, that's a long story, because so I started to use Emacs in 1997 because I heard, Emacs is the most powerful. Now remember, this is 1990s. So there's no 1997, there's no Amazon, there's no eBay, there's no, internet like today. There's no Wikipedia, nothing. There's only like 100 websites, 1997, 200 websites, something like that. So, but in the 1990s, there's no Linux even. I mean, Linux just began. Okay, so you got Unix, you got Solaris, and so on. So I like, so I was a Wolfram language programmer, and Wolfram language is one of the, like very powerful, like on the cutting edge technology. So it is well known for in the math community, mathematics or artificial intelligence, and also in Lisp, because back then Lisp programming language is the well known for artificial intelligence, and in fact Wolfram language is a Lisp. I talked about in my last video and several others. Just search for Wolfram language and Lisp on my website. So I was a programmer of Wolfram language. But then I heard of Unix and GNU, Emacs, like very strange. What is GNU? So I started to look into, and I heard it's the most powerful editor. So I started to learn it. You learn it just by reading, reading the manuals. Like there's a default manual. Like when you start Emacs, they show a manual, like interactive Emacs tutorial there. So you just go through this. That's a beginning tutorial how to use Emacs. Like what is a buffer? They have strange terms. Copy and paste. They don't call copy and paste in Emacs. They call yank, and kill. So, but I'm a nerd, so I learned it, and it's pretty useful. And so I started to live in Emacs by 1998. Okay, then eventually in 2006 I started to learn Emacs Lisp. Okay, before that I already started to learn Scheme Lisp, because their relation with Wolfram language. So I have like a lot of articles about my early experiences. So let me show a few. Okay, so what we want to show. So sign for search. Experience Wolfram. Okay, Mathematica. Okay, Lisp. Where is it? Lisp and Lisp macro versus Wolfram language. Wolfram language versus Lisp. So lots of old articles, like going back 30 years ago. XA on Lisp. Okay, here's my collection of Lisp-related articles. So there's a particular article I'm looking for that details my experience of coming to Lisp from Wolfram language, written like 25 years ago. It might be on xahlee.org. It may not be here. So, all these are pretty old articles, 10 or 20 years old. Famous programmers on how common Lisp sucks. Guy still says, don't iterate, recurse, and get rid of Lisp cons. Paul Graham's infatuation with the concept of hacker, because he's gonna create a arc Lisp, because he want a hacker language. He believed the concept of hacker is the best definition for the best language. Why Lisp macro sucks, why Clojure is dense, Clojure's popularity. What is your favorite Lisp language? Code purity, deception, Scheme Lisp and failure. Why Chi Lisp fails and Clojure Lisp succeed. and Lisp macros and practical common Lisp idiocy, and the car and Kader idiocy, the Lisp cons idiocy. There it is. There, that is the article I was trying to find. Yeah, on xahlee.org. My impression of Lisp from Mathematica. So this is written in 2008. 2008? I think it's written in year 2000s. I think it's written much earlier. Okay, anyway, so that's one of my articles. So I wanted to finish this. I think we are done here, but there's few things I want to talk about. About generators, iterators. Let's see if I have that. Hold on a second. Okay, so this is about the tutorial. It's mostly done. So you have a question. Let's see. So why do I learn Emacs this? Well, because it's, I'm a dedicated Emacs fan, and gradually I just learned more Lisp because Lisp is my thing. Functional programming, Mathematica, that's my love. And when you learn Emacs Lisp, one of the great advantages is that it just makes your editing so much more powerful. Is it environmental? So Emacs Lisp is fantastic. Is it environment, not just single programming language? I do everything with it. CRM, websites, phone calls, SMS, LLM. Yeah. A lot of people do that, but actually I don't use Emacs for anything other than text. So if it's something related to text or editing or writing or programming languages, I use Emacs. Any text, okay. But if it's about playing videos or email, or usually I don't, because in email you got images, you got or videos. It becomes complicated. Lazy sequence in Lisp. I don't think there are. Let me double check. No, I don't think. Oh, that's how you do those pop-ups, or the descriptions are in JavaScript file. Yes. Fantastic. Cheers for story time. Okay, that's it for today. Thank you guys for watching. 1 hour. Okay, 1 hour. So we close down in a minute. So we started to write this tutorial. You gotta begin somewhere, like the Alice in Wonderland. Begin at the beginning, because you don't take the first step, or like Confucius says, the Chinese Confucius, you have to begin, like, what's a saying, I forgot, but you gotta begin somewhere. So so we started here. We need pop-up. Okay, that's good. And this topic box needs to go. This topic box doesn't belong here. However, you need a new topic box that kind of group these. So this data structure box remove, and Emacs Lisp hash table box remove. But you do need a new topic box that's all about this collection of pairs and manipulations. So let's add it. Listify. Okay, link them, list them, then add a topic box like that. And here you'll say Emacs Lisp collection data structure. Okay, something like that. So, and you copy the file path, paste it, linkify, make a list, delete the URL, and you need add that somewhere here. Say what you should say, key value collection data structure. This is very annoying because this hash table or key value collection, there's many names for it. Dictionary, associative list, association, hash table, lookup table, or map. For example, in Ruby and Perl, it's called hash table. Python is called dictionary. Emacs Lisp, you have association list, you also have hash table. They are different things. Then you also have property list, okay? In Wolfram language, it's called association, okay? Not list, just association. In Java, it's called map. And JavaScript, in JavaScript, it's either map or object. So very annoying. You don't have like one central name. Like each of these terms is not optimal, because if you call it hash table, what the fuck is a hash? Then it confuses the concept with the hash function. You want a function that returns a hash key. Confusion with that cryptograph concept. So hash table, well, it's related because you actually hash the key. But anyway, so hash table is not a good term. It should better is key value list or key value collection. That's actually the best term. Map is not a good term because that confuses with the function of mapping something to something. It's like a geometric concept, geometric transformation. That's map. So that's not good. And dictionary is most intuitive, but then it confuses with the English dictionary concept. So anyway, so let's just decide on let's say key value collection. Okay, let's just we don't want it to be too long. Okay, so anyway, let's just say that. Let's just say delete that. Okay, now for each of this page, add this box. Okay, press, that will do it. Okay, now show in browser, hash table, go to the bottom, key value collection, go to association list, go to the bottom. Okay, now go to property list, go to the bottom. So you got all these boxes. Fantastic. So they are great for cross-reference. So when you are, doing association list, you can know that, there's also generic map functions. Yeah. Okay, yeah. If you like my stuff, go to xahlee.info, go to all the way down, and pay me, okay? Amazon gift card, PayPal, Patreon me. $100 is good. Bye.